everybody. I think there ended up being a miscommunication on the time that we were starting. So I see we've got 45 people in here waiting very patiently. So I really appreciate y'all waiting. Let me go ahead and just get started then. So sorry about that. So hopefully you are seeing a screen of mine where you see me superimposed over my intro for the Intro to Cassandra for Developers. Is that what you guys see?
Yep.
Yeah.
Wonderful. All right. And you can hear me okay and everything?
Yeah.
Great. All right. So with that, we'll just get through this. Patrick is actually going to join me a little bit later. He was out. He will show up here momentarily. And with that, what I'm just going to do is I will keep an eye. Let me pull real fast. Let me pull all of you over to the side so I can see you in the chat. So just to be very clear that these sessions that we have, these workshops we do, are always intended to be interactive. So ask your questions, right? Definitely ask away if anything's not clear, or if you need, if you've got a question, just something you're not really sure of, by all means, go ahead and ask. By the way, I did see some of you already active in the chat mentioning you created an Astra account, you're ready to go. That's awesome. I love the enthusiasm. So let's get to it. Okay, so the first thing here that I just want to kind of cover is separate from what we're doing today in this particular workshop, this Intro to Cassandra workshop. We have all sorts of other resources that are out there that are completely free in our DataStax Devs YouTube channel. So if you go there, you can actually find other workshops like this. You can also find the GitHub repo I'm going to share with you today, the project that's part of. There's a ton of other material. We just released an advanced data modeling piece in Cassandra. We're working on some other things. We have some stuff working with Spring and Java, all connecting to Cassandra and everything. So lots of other resources. Now on the right-hand side, you'll see that DataStax Astra page. So we are going to use DataStax Astra today, which is Cassandra as a service in the cloud. This is where you're going to spin up your Apache Cassandra database. Now, the cool thing with Astra and what we're going to use today is there is a free forever tier. There's a free 5 GB tier. It's perfect for developers. And when you want to experiment, maybe you're completely new to Cassandra, you haven't done it before, and it's kind of daunting to go and try to spin up a whole cluster. That's exactly what Astra's for. So we're going to use that today to essentially, that's going to be our database. And then the last one there in the bottom right, that menti.com. So I will ask you in a moment here to come with me to menti.com. That is going to be where we are going to not only do a quick survey, but then I'm also going to have you come through a fun quiz. So as we go through the material, we're going to kind of quiz you on it. The cool thing is the top 3 winners of that get swag, right? So it is competitive, speed matters, all that kind of deal. So it's a little bit of a fun little piece that we do. All right, so with that, then just a couple other resources before I get going. If you ever have questions on Cassandra, any of the content, anything like that, they could be as technical as you need them to be or not. Go to community.datastax.com. It's a great place to ask anything you might really have. There's a full community. There are Cassandra committers that are there, people who actually write the code of the database, who answer those. On the right-hand side, in the top, you see academy.datastax.com. Again, these are all free training courses. There is literally weeks worth of material that you can dig into, especially if you want to get into like Cassandra fundamentals, administration, data modeling, all sorts of things. And again, all that's free. And the last one there on the bottom is the Discord chat. So for those of you, and by the way, we'll provide all these links. It's going to be all in the material that I'm going to give you here in a moment. If you ever want to talk to us and engage with us, whether it's outside of this event or really whatever time, you can always go to our Discord server. We've got about 6,000 people in there right now, other folks part of the Cassandra community. So you can always come and ask us directly. Just hit us up. Okay. There we go. So what I want to do for the moment is we're going to jump to menti.com. So if you would just go to menti.com, and the code is 8988346. I'm going to pop this in the chat. 8988346. There you go. And I'm going to go here with you. 888. Now, what I'd like you to do is once you get in there, yes, I already saw a thumbs up come in. Wonderful. Yes, please. If you can, go ahead and just give me a thumbs up. Let me know that you are, in fact, in the Menti. Excellent. All right, good. I'm seeing, let's see, we've got 45 of us in here. Let's see if we can't get to 20 before I kick it. Six more, come on. All right, four more. I like the thumbs up. Keep them coming. All right, 18. We're real close. And don't forget, like I said, when you get into this later on, we'll do the quiz where you get a chance to win swag. Wonderful. There we go. Boom. All right. So for the first set of kind of questions here, these are really just questions to help us understand you a little bit better, right? Definitely want to understand the audience we have, especially this one. How much experience do you have with Apache Cassandra? Oh, wow. So a bunch of you have never used this before. That's amazing. All right. Well, this is perfect, though. That's exactly what this workshop is designed to address. So we've done a lot of these. I've never seen one where everybody has never used it before. Wonderful. So don't forget to bring your questions. Don't be shy. Have you ever been to one of our workshops before? I have a feeling it's going to be no for everybody. Okay. Oh, a couple of you. Hello to the 3 people who have been to one of our workshops back. And for those of you who are new, welcome. Glad to have you. All right. So what's your main motivation for learning about Cassandra? Okay. So it's like kind of an even split between those who are looking to develop in Cassandra, some for administration. Okay. Okay, excellent. Thank you. And how did you hear about this workshop? Of course, through the conference is probably one of them. I am curious, though, if anyone got any others. Oh, okay. A lot came through email. And why do you search for it? I always love the through friends. That's great. Excellent. All right. And last one, what do you want to do with your knowledge? And by the way, if you're thinking about get a better job, these are all anonymous. Nobody is tracking who's answering what or anything like that. Yeah, you're right, Daniel. MLH isn't an option. I figured a lot of you might be coming through the conference for this one. Yeah, cool. To get a better understanding, hopefully you're going to have that today. Building an app with Cassandra. Now, we may not be building an actual app today with what we're doing. We're just going to intro and get you started with how do you even use this thing, what it is, that kind of deal. But we have actually a ton of other content on building apps with Cassandra. So I do encourage you that when we get to the GitHub repository, if you look at the main project, the DataStax Academy one, you're going to find in there's all sorts of other workshops. They're all built to be self-service, so you can do them totally at your own pace at any time. So you may be interested in some of those. Okay, so thank you so much. Let's leave this window open because we're going to come back to it for the quiz later. Okay, so the next thing I'd like to do, I'm going to drop a link for you in the chat. Let me go ahead and pull it. This is the repo that we're working off of today. Let me get this in everybody here. There you go. So this is where we're going to be following along, right? Now, however you decide you want to do this workshop is totally up to you. You can listen along. I'm going to go through all the materials, all that kind of thing. You can also go through it with us, right? You can do this real time and get set up and do all that. Either way, totally up to you. If at some point you do get behind or anything like that, no worries. It's all completely self-service. So it is meant for you to be able to come in at any time. You can do this completely on your own. So don't worry about that if you were to get behind or anything. Oh, I did. Did I not send it? I dropped it. I put it to everyone. Maybe I didn't put it. Oh, my bad. Here you go. There you go. Thank you for pointing that out, Yash. Yes, there's the link. Let me know if you have the link now, please. Wonderful. Okay, thank you. I was dropping it in the wrong place, and looks like you're getting it. Excellent. Thank you guys for all responding. Okay, so one thing I did kind of gloss over just a moment ago because I wanted to get into the Menti was Astra. As I did mention, that is the database we're going to use today. So it is Apache Cassandra under the hood. What it is it's just a fully managed Cassandra without the operations. So this is, again, Astra is really developed with developers in mind. It is, if you think about it, when we're coding up applications, we don't really want to have to worry about the database layer. A lot of folks in their organization, maybe they have, IT is supplying their Cassandra database or something, but sometimes when we're just starting something up, or if we're trying out a new database, we don't want to have to go through all of the work of, spinning up a whole cluster and doing that. So that's what Astra really does. A lot of the capabilities of Astra are really geared towards making the development process a lot easier. So again, we're going to spin one of these up today. We're going to do it here in a moment. And then what's really neat is once you have this up, it takes just a couple minutes. You have a fully baked Cassandra database. And then to connect to it, you can connect to it securely with something called the Secure Connect bundle. We're not going to work with that as much today, but because a lot of you are developers, I just want to point this out, that it handles all of the TLS, SSL, secure connections to the cloud database that you're getting. It's something that literally in that one bundle, you just drop it in your app and then you just pass that through to your driver and that's it. It makes it a lot easier to get going. So it's really nice when you are experimenting and you're kind of like figuring out your data model or how to work with Cassandra. And then the last part I'm going to say about that is once you've spun up a database in Cassandra, the DataStax drivers are universal, regardless if you're using open source Apache Cassandra, DataStax Enterprise, Astra, whatever. So once you've coded your app and you've set up the driver, then you could just, if you had your own Apache Cassandra, you could just switch right to it, right? There's no code that you need to change, same driver, same everything. Okay, so here's what we're gonna cover. We actually have two main sections of the content today. The first part is I'm gonna give you just kind of an overview, a primer. Tables, partitions, key spaces. What are those things when we're talking about Apache Cassandra? Then we'll see, hopefully, Patrick will be jumping in and bring you through the art of data modeling, right? This is where we look at kind of the paradigm shift. So, for those of you who may be used to doing things in the relational world and using relational databases, we've done things a certain way for decades that way. In Cassandra, it's a little bit different, right? And there's a good reason for this. But it is a little bit different. So if you're used to doing things that way, it kind of helps to understand what that path is. That's what we're going to get into in the art of data modeling, kind of, focusing in how do you properly data model with Apache Cassandra. And then we'll leave off with some resources and such. Okay, so the first thing is the smallest unit store any kind of data in is going to be a cell, right? This is essentially the intersection between a row and a column. That's where you're going to store some data. Anybody who's worked with any database, spreadsheet, anything like that, they're probably familiar with exactly what this is. Now, the next section, then you build that up, go from a cell, now we go to a row, right? Now we're going to have a single structured data item in a table. Just one row is going to usually be a set of related cells, right? So we have John, like we did before, but now we have some other columns of information. These are related, that they all go together, that forms a row. Now this right here is where we start to get a little bit different when it comes to Cassandra compared to maybe how you've done things in relational databases, what we call partitions. So really partitions are going to be groups of rows that are all related. What I want you to really note on the right-hand side, that department, notice that department, they're all wizardry. Now, in this case, we're actually storing a partition. We're actually creating a wizardry partition. This has, by the way, everything to do with how Cassandra stores data on disk and everything. I'm not going to go there right now. If you have a question, feel free to ask it. But just understand that Cassandra stores data in partitions. And like any data that's stored, rows that are stored in the same partition, right? those are all going to be related. So in this case, I can see that John Doe, Mauricio Chapez, and Maximus Flavus are all part of the wizardry department, and all those would be stored together physically in a partition wizardry. Okay, so if we look at the structure overall, right, you start with a key space. A key space in Cassandra is essentially where you set your replication factor and where you store all your tables. This would be equivalent to a database or a schema in the relational world. Then within a key space, like I said, you've got tables. Those tables have columns and rows, just like anything you might be used to if you've come from doing things again in a relational database. But the difference are these partitions, right? I mentioned these partitions before. So data is actually physically stored around your Cassandra cluster by partitions. And in order for that to work, when you create a table, you actually, at a minimum, are required to create what's called a partition key. So that example we saw a moment ago of, my clicks are not working. Here we go. There we go. The example that you saw a moment ago when I was talking about a partition and a partition key with wizardry, this is what I'm talking about here, right? This is what I'm talking about. So I have a partition key. Maybe my partition key would be department, like in this example. So I have a wizardry department. That would be a partition. Maybe I have, a fighter, a fighter department. Maybe, maybe I have, I'm trying to think of the name of one of the departments, or what do you call them with bows and arrows? It's not coming to me, but I'm trying to go with the RPG thing, and I'm missing the bows and arrow one if someone wants to give it to me. But you get the idea, right? So these different groups, different departments, each one of those is a partition key. Each one of those are going to be physical partitions that are stored that represent the data in my table. So let's look at a concrete example of that. So here I have my killer video key space. And again, the key space is where I'm going to hold my tables. In that, I have a table, users by city. Now in Cassandra, the convention we use is, well, you see that by city. I'm partitioning by city. So I have a users table that's being partitioned by city. So if you take a look at this example, notice that my partition key column is city, and I have two, Phoenix and Seattle. And notice in each of Phoenix and Seattle, they have a set of rows, right? So I actually have a physical partition Phoenix and a physical partition Seattle, each with their own sets of data. Now, if you look to the right, you're going to see these clustering columns, last name and first name. Clustering columns are really there for order or uniqueness, right? So notice that I'm ordering by last name, then first name. So what that means is as I store data in Cassandra, it's going to be naturally ordering the data as it comes in. So if you notice here, Helson, HLS, Helson, Lastfall, Smith, these are being naturally ordered. I don't actually have to do anything there. That's actually being done for me on the right, right? And then the first name would be ordered by the last name. We don't have any variations. Imagine I had two Helsons, though. Maybe one's name was David or something. So David would come before Kevin. So I would see Helson David and Helson Kevin, so on and so forth, right? So that's one way you can use clustering columns. And it's the same thing here. Notice down in the bottom, I have F, then JAC, JAS. So it'll be naturally ordered if I use a clustering column. This is actually a really nice optimization because it's done on the right and it's done in memory where it's fastest. Later on, when you read the data, you're reading it out already in that ordered fashion, literally off disk that way. Cassandra is built to be able to maintain its speed and performance at scale. And that scale could mean thousands and thousands of nodes. We're talking like petabytes of data. And it is optimized to work that way. So think about it. In a relational database, where do you pay for the order? You pay for it on the read, right? Now, I want to be clear. I may make some comparisons to relational databases. My goal here is not to like crap all over relational databases. They're general purpose databases. They have served us well for a long, long time. But Cassandra and other NoSQL technologies really came about because of a need to be able to scale and perform well past what relational databases can do. And so the reason why I point this out is there are a lot of concepts that we're going to talk about that you might be like, well, why did they do it this way? It's for this very performance. It's to be able to maintain all that performance at scale. Okay, so enough about clustering columns. And then the last piece after my partition keys, my clustering columns, if I have any, are my data columns. This is really the payload, right? The things that are in my partition key and my clustering columns really form my primary key. And then anything else is the data I'm really looking to get out of my table. Okay, so let's look then at how do you do this? How do you create a table in Cassandra? Well, if you're familiar with SQL and relational, this is going to look very familiar. It's supposed to. This is done with a language called CQL, which is actually a subset of SQL. So it is meant and it's intended to look and feel like it. So notice I have create table. There's my key space name dot my table. So I'm going to create table killer video at dot users by city. Then I have my column definitions, right? So I'm going to give whatever the column names are and their types. And then after that, I'm going to set my primary key. Now, all this should look pretty familiar, again, if you come from the relational world. The big difference is that in Cassandra, you're required to have at least one partition key, right? So the first value that's in your primary key, in this case, city, will always be that partition key. So anything that comes after that are clustering columns. So I'm saying I'm partitioning by city, I'm clustering by last name, first name, and then email. That's how I'm setting up that primary key. Oh, and I do see a question. Hi. So hi, Suhani. So partitions are basically records grouped by a particular field. Is that right? Yeah, that's right. And let's see, Nikirka. It's like an identifier and how it distinguishes info. Yeah, if you're referring to either the partition key or those clustering columns, yes, the partition in particular is definitely an identifier how you're distinguishing your data, or how you're grouping your data, right? When I say I want to partition by city, I'm literally going to be storing different partitions around my cluster that are being stored by that city. So the example we saw with Seattle, Phoenix, it could be Chicago, Orlando. Every one of those groups will be a different physical partition that is stored around the Cassandra cluster. Let's see. Yeah, so let me know, by the way. Oh, I saw another question by Kevin. Are the partitions to speed up access times? Yes, totally. Great question. Not that the others weren't, but that you really hit on something key there. So again, Cassandra, as you will hear me nauseatingly say, is really built to be able to maintain its speed at scale. So one way to do that is to reduce the number of reads. You want to reduce the amount of I/O you need to return data back to you when you go to read it later. So what happens is by storing the data in these physical partitions, if I had, say, the example we had a moment ago, if I go back, Phoenix, that means that if I want to query Phoenix and I want to get any of the information from those 3 rows, I can perform one read. One read, boom, I pull that data back right in one shot. I don't have to go scanning around my cluster. And especially in a distributed system, imagine too, again, if I had a 1,000 node cluster or something like that, I don't want to be reading that data from those 3 rows all over my cluster. I want to be able to read it as fast as possible with the least amount of I/O. I saw a question come in. Let's see. Dia is a read the info cell. It depends. It depends. The read usually is going to be at the partition level, right? So I'm going to be reading from the partition. Now, if I want to grab an individual cell, I can do that just fine. In my select statement, I would say select last name from, users by city where my partition equals Phoenix or something like that. So I could, but it's not individually at the cell level. It's going to be at the partition level. Okay, and I see a question from Deepanshu. Are you saying that the partitions can be stored in different locations geographically and then again can be combined on a read? Yes, I am. So partitions like the example we have, like Phoenix and Seattle, would in fact be stored in different nodes around your cluster. Then now, when you read, generally you're going to select by partition, which means that you're not going to be doing this like scatter gather kind of thing. If you were to perform something like a select star, right, on your table, and matter of fact, let me go to a different slide for that one for you. Yeah, imagine here I've got these different partitions, these different physical partitions that are stored on different nodes. If I were to perform a select star, in that case, logically, I would see all of the partitions, right? But I'm actually going to have to now go get that from all of the nodes. So to answer the question, yes, are they stored in different locations geographically and then can be combined in a read? Yes, the answer is yes, you can. But generally, as I'm going to show you, when we select, we're going to select by partition because that's going to be the fastest thing. The reason why, by the way, we'll talk about this a little later. We usually kind of discourage people just doing a straight select star with no constraint in the where clause. Reason why is, imagine you've got a petabyte of data in your table and you're spread amongst a huge cluster. If you do a select star from users by city with no constraint in the where clause, you just scanned your entire cluster, right? Cassandra is really going to perform for you when you use those partition keys. Okay, and last one here. What's the killer video? Oh yeah, killer video. Killer video is just the key space name. It just happens. Killer video, funny enough, is a reference application that we've written that we use to kind of help people get a starting off point, not like how do I code with Cassandra. It's just the key space name. It's the domain that we use for the particular app that we are pulling these examples from. Okay, so moving on. So let's take a look then at some of the methods that you want to use when you're thinking about your primary key. So I mentioned that the partition key itself is always required, right? So that you need that at a minimum. And then after that, you can add clustering columns if you need. But there are good ways to do things and bad ways to do things. So this is really what I want to get out here. So look at the two good examples. Notice the first one, primary key, where I have city is my partition key. Last name, first name, and email are my clustering columns. Now, why is this a good example? Well, let's take a look at the bad example down at the bottom first to see why. So notice this one in the bad example on the bottom. I have city as my partition, last name and first name. Now think about what might happen here. What happens if I have two John Does in the same city? Which one's which? Well, in the case of Cassandra, if I did have a case like that, last write wins, right? That's another optimization that Cassandra has on its writes. There is no read or write. It literally appends. It can write in the order of microseconds to very tight milliseconds. And it achieves this by not performing a read before write. There's no comparison. It's last write wins. So if I had one person who came in and the city of Orlando with, Doe John, and then I had somebody else come in, Orlando, Doe, John, that last one is simply going to win. So what's going to happen in that case is I might actually lose some data. That's why that's a bad example. So if you take a look at, go back up to that first good example where we add on email, email now is giving me uniqueness, right? Because email is generally guaranteed to be unique per user. So this way, if I had two different John Does, well, there's a very, very good chance they're going to have different emails. So now I'm making a row unique, and that's really what you're after. You want your primary key to denote row uniqueness. That is what you're after. That second example there, where it is just user ID. In the case of Cassandra, we use UUIDs for our IDs. We don't just regular use integers, like regular just incrementing ints or something. Those UUID is going to be unique per ID. So that's actually a good case, because for every single user in that case, I would actually have an individual partition, and they will be unique. That's enough. That user ID is enough to maintain uniqueness for a user. Okay, I do see some questions from Suhani. One key space has multiple tables? Totally. Yes, you can have you can have n number of tables in a single key space. A key space is the container of tables. You can have multiple key spaces and the same database as well. Mij, I see we could use timestamps as unique keys. You can. Matter of fact, we'll have an example later of a time UUID. You can totally do that. You might want to, time UUID is really the proper type for that if you want to use that as a unique key, because you could actually have two events that have the same exact timestamp. So yes, the answer is yes, but time UUID is the way to do it. Let's see. Kevin has a neat question here. Let's say we use the first example and we're creating a new user and someone enters the same email and the same name twice. Do we lose the first one? Absolutely. If it is identical, yes, it'll do what's called an upsert, right? And that last write will win. So if you have a case where you're concerned about that in your particular data model, what I would suggest to do is just add in another piece that will ensure uniqueness. There's all sorts of patterns to do that. Now, the good thing is email is kind of a natural key. You could argue that you have two people in the same household that are maybe using the same email and one person has inherited the name from the other person, right? Then if that's the case, then you would want to control for that. But you're correct. If two people came in with the same exact name and email and the same city, yes, the last one would overwrite. Let's see. Let's see. Now, the second good example, won't it be a bit slower? Given that each individual user ID will have its own partition? No, right? Because Cassandra is really optimized to be able to pull those partitions back. So I would ask to follow up. What do you think might be a little bit slower there? Okay, I see some questions. I'm going to move on because I want to get through some more content, but I'm going to try to get to these as much as possible. Okay, so now in this case, right, you have that we're kind of looking at the partition key. The first one, we were kind of focusing more on your primary key, the fact that you want to ensure uniqueness, and you might define some sorting there. In this case, your partition key, if we focus there, it's about partitioning rows, right? Now, the one thing that you want to really keep in mind when you create your partition keys is to not leave them unbounded. Even though you can technically store as much information as you want in any given partition, there are practical limits. We usually say that you want to keep your partitions within about 100 megabyte of partition, or about 100,000 rows per partition, right? So again, that's not per table, right? I can have as many partitions as I want in a table. I can have billions of rows in a table, but that needs to be separated out by these partitions. So the first example there, the one with user ID, again, that's a case where we're saying, well, each user will have its own unique ID. So that's actually a good example. The second case there we see with video ID and a comment ID, right? So let's say that my query access pattern is I'm looking at a video in my app, and for each video, I want to retrieve all the comments for that particular video. This could be a way to do that. Now, the bad example at the bottom is kind of interesting. Let's say I had an individual sensor for a sensor ID, maybe an IoT kind of setup, and then I'm going to log information on it, say every 10 seconds. The way that is set up right there, it's completely unbounded, right? After a week, right? Imagine the amount of data I'm going to have for that one sensor. And if it was left to go, if anyone's ever stored SNMP or SMTP data or metrics data off of network devices, server devices, you know how quickly that data can grow. So even though from an IoT standpoint, that bad example at the bottom is okay, it's missing a constraint there, right? I'll get into that later. But right now, as it stands, that particular primary key that you see with sensor ID and logged at is unbounded, right? That's why we're saying that that's a bad example. So if you move back up to the second good example, you might say, well, wait a minute. Couldn't you have a billion comments for a video? Isn't that unbounded? Yes, it technically is. In a case like that, you really need to look at what do you expect in your data model? How many comments do you really think you're going to have in a video? If you feel like it's going to be a lot higher, you're going to have thousands of comments. Maybe you have a celebrity on your system, or maybe your social networking site or something like that, and YouTube for all you know, and you have a ton of interaction. Maybe you do have a case where you could actually have thousands and thousands of comments per video. In a case like that, I would say you just need to look for a way to split it up a little bit. You can do that, no problem. But generally speaking, you're not going to have that many comments, right? So again, it's really about keeping it so you're not just leaving your partitions unbounded. Okay, so let's take a look at clustering columns a little bit. So clustering columns, again, can be used for uniqueness and for ordering. So let's look at the first example. Now, in the first example here, again, we talked about the uniqueness part already. If I have just city, last name, and first name, it's not unique. I have two John Does in the same city. If I had a case like the second one, we add an email, that's pretty much going to be unique, right? We know that each one of those rows will be unique. Now, if you look at the bottom example, the top one, we were just talking about this a second ago. If you think about it, if I'm going to display comments in my app, I probably want to put them in a time-ordered fashion, right? Because if there's a conversation going on in my video, I don't want to have a case where the comments are just kind of placed randomly. That wouldn't make sense, right? They generally come in a time order fashion. So this is where I can use a clustering column to order the data. So in the top case, it's not ordered. The comments could literally be random in order. But in the bottom case, we've added this created at, the timestamp in there as a clustering column. Now the data will be naturally ordered based off of the created at date, right? So that's just kind of giving an example there of using a clustering column for ordering and where that can help. All right, I saw some questions come in. Let's see. Kevin, you probably were asking a question, does it overwrite or add a separate entry? You were probably asking that from something I was saying earlier. If it is a case where if it is the same values, right, where we talked about like city, last name, and first name, it doesn't, it is a separate entry. What actually is happening in the database is the write goes in and it has a newer timestamp. The previous writes, right? So if I had a previous Orlando John Doe, those previous writes exist in what are called SS tables, the immutable files that actually get stored out in disk. But they have earlier timestamps. Then on the read, it does that comparison. It gives you the one with the last timestamp. Now, the first question that comes to most people's minds is, wait a minute, so that data is just sitting out there. What happens to it? Isn't that going to make my read slower? So what happens is there's a process called compaction that's automatic. It's not something you have to actually worry about. That goes through and that cleans that stuff up. So as data is overwritten, if you will, it'll be cleared out over time, right? It'll get compacted out. And eventually then you don't have to do that comparison anymore. So it's not really overwritten. It's more appended with that latest timestamp is what's going on. Yash says, is there a way to check if some data is already in the table? Yeah, yes, you can totally do that. So as I mentioned earlier, I said in Cassandra with writes, there's no read before write by default. If you do need to perform a read before write, if you need to perform a check on some type of data before you do a write, you can totally do that with something called a lightweight transaction. That will, in fact, perform that read before write if you need to. By its very nature, though, that's not going to have the same response time, right? It's going to slow things down a little bit because Cassandra uses an append-only method when you're writing data to make it fast is the point. So yes, you can read before write if you need to. Generally speaking, though, in Cassandra, you don't need to worry about it. There are some cases where that comes up, but most of the time you're gonna model in such a way where you don't need to do that. Okay, so some general rules of a good partition. Cassandra uses a denormalized data model, different from what we're used to in the relational world. What do we do in the relational world? We use normal forms, right? We use multiple fact tables and join tables, and we join our data together. So for any particular single query, I might very well be hitting multiple tables and then doing like a Cartesian join or something. In Cassandra, it's denormalized. I'm going to store everything I need for a particular query in a single table, and I very well may repeat that data. Patrick is actually going to talk about this a little bit more later. This is another optimization. What it really comes down to is this. At the time that relational databases were created, disk was really expensive. How many here, if I can get some thumbs up, remember these huge platters like that were 5 megabytes and extremely expensive and not very fast? I mean, you had physical spindles, right, and things that had to move to get the data around your disk. So things were designed to reduce the amount of data footprint and such. But over the decades, things have evolved quite a bit. One of the cheapest commodities there today is disk, especially with SSDs. So Cassandra balances, it makes a trade-off. It says, okay, I'm going to use more disk in a denormalized data model, but I'm going to get faster read times. And this, by the way, is exactly what you do if you have ever done data warehousing, right? Even in a relational database, if you do data warehousing and you need to speed up things, you will flatten out in a denormalized fashion. That's what's happening here. So the point being, again, when I mentioned you want to store together what you retrieve together, because then when I go to get data out of a partition, that single read will give me all of the data back. I thought I heard someone pop a question. Okay, we're good from that standpoint. Okay, so in the first case then, from that standpoint, when I want to retrieve the comments for a video, notice I'm storing the video ID, the time, and that comment. I've got all the information in there in one shot. So with a particular video, I get the comments. I don't need to do anything else. But in that second example, one with the big red X, I've got all these comments, right? But I don't have the association with that video or anything like that. So for a particular comment ID, I have to go find the video and do a subsequent read. So I want to store together what I retrieve together. Okay, so another one, and I kind of alluded to this before, is you want to avoid big partitions. So generally speaking, even though there's no technical limitation, it's best to keep your partitions within about 100 megabytes. 50 megabytes is actually a good sweet spot, and about 100,000 rows per partition. So in the top example, we've already talked about this one. This one, I'm only going to store the comments per particular video, right? If I really do have a case where I have more than 100,000 comments per video regularly, then maybe I'll add something here to my data model to reduce that. Look at that bottom example with the red X. Think about this one. If I only partitioned by country and user ID, I would literally be storing all the users, individual users per country. Imagine a country like India compared to, say, a country like Iceland. I could have this huge partition. I mean, I've got, what, 1.7 billion in India now or something, right? So I could have this huge partition if I stored my data like that. Where then on the other side, I may, for Iceland, I might not have, near that number, right? So this is what we're talking about saying avoiding big partitions. You want to avoid partitions that are going to grow very, very, very large. Okay. All right, and then going back to the example we were talking about before, from the big and constantly growing partitions, this is what I was referring to. From IoT standpoint, if I have my sensor ID and I'm going to record some data on that sensor, say every 10 seconds, that itself is fine. But you don't want to just do that indefinitely because that partition is just going to continue to grow and grow and grow. However, notice what we're doing here. This is actually called bucketing. So we've added month year. We've added the month into the partition with my sensor ID. That means I'm automatically kind of bucketing the data per month. So I'm capping it, right? That means for a particular sensor ID, now I'm breaking it up per month. That's more manageable. Maybe I do it by week. Maybe I do it by day, right? It depends on the data that you have and your particular needs. But this is what I meant by there are ways or methods you can use to kind of break up the data. Okay, so for hot partitions, hot partitions are related to big partitions. If you have, going back to the example before, if you look at the bottom with the red X where we have country and user ID, if we use that example where I have India, which is a huge country with a ton of people, and if I had a user for every single person in India, I would have well over 1 billion values in this one country, 1 billion rows. So not only is that a very big partition, but there's a very good chance that with all those people, that there's going to be, that partition is going to get the lion's share of use, right? That's what we mean by a hot partition. So if I have partitions out there, but I have one partition that's getting most of the traffic, right? That's a hot partition. So that's why, again, big and hot partitions sometimes can be related. So again, you want to prevent having that. Now, somebody asked a case about performance earlier with just user ID. In the case of user ID, I'll have a unique partition for every user. Even if I have one individual user that gets sees a lot more traffic than other users, generally speaking, it's not going to be on the order of what we might see in, having a big India partition or something like that. And it's very well distributed and it's a very measurable, easy to know size for the individual user. So I know I'm going to have lots of partitions that are around. But the cool thing in Cassandra, those partitions are essentially the address. Right. So when you write your query, you're telling it where the partition equals what, and Cassandra knows exactly where to go and get that. So this is actually pretty efficient to have unique user IDs that way. Let's see. So I see some questions. Yeah. Oh, okay. So Yash, you got it. It seems like you were asking, I don't get what hot partitions are, but then I see the So let's see. Let me know if I can get that right. Yeah. Okay. And then I see Mij answered it. Got it. Okay, but you explained. Wonderful. Okay, don't mind me as I read through these. Let's see. Suhani, is there a way to make partitions within partitions, as in first partition by country, which is further partition by state? Yeah, that's kind of what you're doing in the case. It's not partitions within partitions, but if you take a look at the second example here, sensor ID and month year, we're partitioning by both in that case. It's called a composite partition. That's exactly what you're doing. So if you do have a case where you actually need a partition by multiple things, you can totally do that. And in a lot of cases, that's a good way to handle that kind of thing. Can you shard? I seek from Kevin. Can you shard a Cassandra DB, or is it practical with partitions? partitions are really shards, if you think about it, right? There is actually something called synthetic sharding in Cassandra. That is where you kind of introduce other columns that you kind of want to separate or bifurcate your data by. But Cassandra, by its very nature, it is essentially a sharding system, right? That's what that. It's not the. Don't get it mistaken with the first kind of sharding that came into play with relational databases and such. They had a lot of problems. Cassandra evolved, out of that after those types of things. But it is really sharding. Partitions are effectively shards. Let's see. Okay. All right. Good. All right. Moving on. All right. So let's go ahead and get into some actual hands-on. I know we hadn't gotten there yet. And what I'm going to do is go over to our README into the GitHub repository. I'll drop it again here for you. There you go. Okay.
Hey, I don't know if you noticed, I showed up, man.
Oh, hey, Patrick's here. Woo! All right,
I've been here
let
for a
me
while.
get Patrick's head on. Let's turn on Patrick's head.
The questions. Why can't I see the questions?
Yeah, let's. Oh, are you in the Zoom?
No, I don't have a Zoom link.
Oh, well, that's probably why you don't.
I have a lot of Zoom links, just not this one.
All right, give me a second, and I will make your head show up.
Are you gonna make my head appear?
Yes, your head has appeared.
Oh, okay.
And everybody should see. Do you guys see Patrick? Let me know if you see Patrick and you hear Patrick. Okay. Yay! Yeah. Wonderful. Thank you.
Yay!
Woo! All right.
Apparently, there's a difference between 10:30 Pacific time and 10:30.
Yeah,
Eastern.
there was a little, I think, miscommunication on or misunderstanding with the time zones. We're doing it. We're all good. We're all good. It's all good.
There's only 28 time zones to pick from.
Yeah, so. Yeah. There's only a couple. Okay, so Patrick, I will get you a link to the chat in a moment. I want to get them all.
I'll let you continue.
Yeah, I want to get them all started up.
Sure you know
for instance going. So the first thing we want to do here is you'll see this link. I'll drop this for you. Let's go ahead and pull up our Astra link. All right, here we go. And again, you can just follow along in the README as well. And you're going to go there. And again, we're going to use the free tier today. Nobody should be putting in credit cards for anything or paying for anything. And the free tier is free forever. Let's see. And then you should get a screen that looks like this. Now, if you haven't signed up before and you're totally new to Astra, you can sign up with Google, GitHub, your email, whatever. It only takes a moment. And again, we don't do any like weird sneaky stuff with emails or anything like that. Or, money. It's like the free tier we're going to use is free forever. Matter of fact, I'm going to go ahead and kill mine so we can just do this brand new.
Free is synonymous with no money.
Yeah, no money.
Yeah.
That would be really not cool.
It's very low cost, as in zero.
All right, good. Yeah, we'll get this going like this. Okay, so when you first come in, you're going to see a screen that looks something like this after you register. Now, what I'm going to do, just to set this up a little bit, I'm going to bring you through what you need to do, but I'm going to give you a moment to catch up, right? So if I'm going a little too fast or something, don't worry, I will give you a moment to catch up. I just want to show you what to expect. So the first thing we're going to do here is use the free tier, right? That's clear that we use the free tier. If you pick one of these others, this actually starts costing things. You can see the cost is right there in front of you. That's not what we're doing for today, so I just want to be clear about that. Once you choose the free tier, you'll have a cloud provider. Astra is provided in all three major cloud providers. Now, you may notice that only Google Cloud here is lit up. That's because I'm using the free. If I use some of the other higher tiers, then the other ones will light up. But that is part of the free tier. We're kind of gaming where you go. Once you choose your provider, then you have a region. Now, again, in the free tier, we're only providing these two. If you were to provide one of the other tiers or pick one of the other tiers, you see a whole other set of regions. Now, I'm over in the East Coast. If you're in Europe or something, maybe you want to choose that one. Just choose the one that's closest to you. The cost here doesn't really matter. Once you've chosen these, you should see this nice little configure button light up, and you pick that. Now you get into creating your database name, your key space, and everything. You can technically put in whatever you want here. However, I ask for today, as in the instructions, matter of fact, yeah, it's in the create your Astra instance section. And if this needs to be bigger, let me know. Actually, I'll just zoom in a little bit. We provided these values though. So I'd ask you for today, just use these values. because that way, if anyone has any questions later or anything, it makes it much easier for us to help troubleshoot or whatever. So I'm going to just copy these right out of here. Database name here. Okay, killer video cluster, key space name. Again, for your use, you can use whatever you want. We're just using these today to make it easy. I'm going to say KV user, grab that password. And here we go. Okay, you'll notice once I fill these values out, I get this create database button. I click that and boom. Now you'll notice my status is right now pending. Once it's ready, or two, it'll go to active, right? So I'll let you all, if I can get some thumbs up, let you kind of get into that. And for those of you who are going to create the Astra databases with us, and again, you should see it'll go to this green active once it's there, and it should just take a couple minutes, and I'll give you a moment. Oh yeah, of course I give you the GitHub link again. Yeah, just a second. Here you go. Oh, of course. By the way, I really appreciate the questions so far. Patrick, everyone's been nice and interactive here this morning. All right, I'm gonna give me 2 seconds as you see behind the fourth wall, and I grab the information.
Well, I like the morning. You get to drink coffee.
Yeah, right.
Make, yeah.
All right, let me
So much
drop
better
this
than doing
over
this at
to
night.
Mr. Patrick. All right, we're gonna freeze for just a moment. There you go, Patrick. Should be back. And you should have the link. And that way Patrick can be in the chat as well. Okay, notice now that my status went active. So my database is good and ready. And if anybody if you've gotten to the point where it says pending, give me a thumbs up. Let me know in the chat. I just want to get a couple of you so I can kind of gauge where we are time-wise. Wonderful. Yay. I got a couple of them. Excellent. Active. Yeah, it should go pretty quick. I mean, it could take up to 10 minutes, but honestly, I've seen it take that long in quite some time. Wonderful. Thank you, everybody. Great. So I see that some of you are getting your databases active. Now, again, this is free forever. This is for you to do whatever. Something I want to point out today is even though we've created a database with a key space called Killer Video, if you want to create other key spaces in the future, you can totally do that. I'm going to do it here just to show you in a second. Let's see. Yes, Hamida, you select Google Cloud for the provider. When you're using the free tier, you're going to only be allowed to select Google Cloud anyway. So like I said, the other tiers will allow you to select whatever provider you want. But right now, free tier will only give you Google Cloud. Yeah. All right. I see that a couple of you are probably still working on it. So I'll just show you a couple more things. And then we'll go ahead and move on. Okay, so we get the active database. Wonderful. You now have a Cassandra database that you get to work with. So what I'm going to do here is I'm going to click on the database. This is going to bring me to the database detail, right? We're not working with adding more key spaces today. I do just want to show you this feature because it's easy and it's awesome. Down here, notice that I have in key spaces, I've got this Killer Video key space. Let me blow this up a little bit. Now, what happens though if I've got some other project I'm working on, or I've got some other domain I want to work with? Well, I could just say add key space, and I say MLH or something, right? I save that. And by the way, you may have noticed I put that in caps, but by default, Cassandra is going to store that in lowercase. But now, boom, I have a new key space. Both of those are accessible to me. I can add n number of key spaces, even in the free tier, and mess with them. So it's a really nice way if you're experimenting with multiple things, different domains, you can just add different key spaces to hold your different sets of tables. Okay. All right, so I think we're good on the actives. So let me go ahead and, Patrick, since we started off a little bit differently, what I'm going to have them do is create their first table and then flip it back over to you.
Sure, let's do that. I mean, we only have, 20 minutes left? So
yeah, right? Yeah, matter of fact,
so I don't know if we're going to be able to pull that off. We started way late, so I'm trying to think of, what's the best way to... I mean, I could bang through the important stuff there, but, just getting people in there, yeah. What do you think?
I want to let me at least show them this real fast. And
sure.
Oh, well, I'm saying, yeah, Yesh is asking quite a few run over time. It shouldn't be that much of an issue, maybe. Yeah, let me ask our moderator friend. and see what we could do about that, because honestly, we're good to continue on, but I want to be respectful of folks that might be coming after us. And to those of you who may have somewhere else to be. All right, let me see what kind of answer I get. In the meantime, what I'll do, and all the information is right here in this README, right? So that's not going to, okay. Okay, it looks like we are getting the green light to continue on. So I'll just go ahead and go through this like we would. So once you have your database and you go into, again, click on your database name, you go into the detail, right? At the very top, notice you have a CQL console. So if I click on that, it will automatically log you into a CQL shell where you can start to then work with the database directly. Now from here, remember, I created a killer video key space, and then I created an MLH key space. So what I'd like to do is just take a look at my key spaces and say, describe key space. So notice killer video. And funny enough, by the way, a normal convention in Cassandra for your key space and table names is just to use lowercase. The reason being, in the way the data is stored, is if I use uppercase, you can technically do it, but then you have to worry about quotes and stuff. Just keep it lowercase. Snake case is really a good way to do it. I just did that for fun because MLH is capitalized. But you'll notice I have both these key spaces. Now we're working with killer video today. So I want to change the database to go into the context of the database I'm going to work with. So I'm going to say use killer video. And now I'm in the context of that key space. Now I don't have any tables. We haven't created anything just yet. So it's going to be empty. But this is the way I'm telling the database, hey, I want to go to this key space and I want to work with that key space. And this is, by the way, what I'm doing right here is also in the instructions, right? So if you scroll down a little bit, you'll see that I did describe key spaces. We see those. I'm using the key space, right? These are just some of the basic SQLSH commands. Now in this next section, what we're going to do is, you can just cut and paste this, by the way. When it says command to execute, that's all I'm saying is just grab this out. We're just going to create this table. Now this table should look familiar. This is the one that we used there in the beginning. I'm just going to paste that in. Give that a second. And my wife dropped off a beer. Isn't that amazing? A beer showed up next to me. Yeah.
Because it turned noon in the East Coast.
Yeah.
Now you drink. That's
lunch beer. Yeah. So I create the table. Now notice when I say describe tables, boom, I have users by city, right? And if I want to, I can also describe the table users by city. By the way, if you notice, I am using tab complete. I'm not that efficient of a typer. So I'm using tab complete to finish those off for me. And if I say describe table, users by city, now I'm going to get a lot more information here, but you can see this table here is the table we created up here. All this other information, right? This stuff down here isn't really something you need to worry about here. There are all sorts of options that you can actually configure per table. Astra will constrain you on those. It's not going to allow you to modify a lot of these. If you manage your own Cassandra database, you can play with these. That's really getting into a lot more advanced topics. So you can ignore that, is what I'm really getting at. All you need to do is pay attention to this part. Let me see. Okay. All right, cool. All right, so with that, we'll finish up on that spot. So for those of you who have tables created, you have the users by city table created. If I can get a thumbs up or a bump in the chat to let me know that you're there. Wonderful, yeah, and those are quick. Let's see, I see Yash says, so is this linking back to the if not exists thing that I mentioned before? Totally, yeah. So if not exists is, Patrick, so you know, I don't know exactly when you came on. I was talking about when Cassandra performs writes that it doesn't do a read before write with exception, right? The exception is going to be something like a lightweight transaction. That is where if not exists comes into play. Yes, so if you use if not exists, you are performing that read before the write. In the case of like a table creation, yes, you could say, create table, if not exists, right? So if I were then
and for reasons, right?
Yeah.
When you have more than one computer, it's not just that read before write has some cost, and that is you have to lock everybody. You have to say stop. You can't do it. You can't modify this yet. And when you put a lock on anything, this is one of the things we learn in computer science is locks equals slow down.
Yeah. So exactly.
Unless you ask for it, we're not going to slow you down.
And imagine, because I like to use the 1,000-node cluster example. Imagine performing a lock across a distributed system with like 1,000 nodes, right? That would be terrible, right? So yeah, again, Cassandra is.
Well,
go ahead.
And it does happen at scale. I mean, Apple uses a lot of lightweight transactions on iCloud. Okay. So I mean, whenever you're doing transactions on iCloud, that's an LWT. But they know just that one thing. So like when you're purchasing something or you're uploading a photo, it'll lock it for just that one little thing instead of like the whole thing.
Right. Okay, so I did get a lot of yays and dones and stuff for the table creation. Right. So pretty much, I mean, right there, congratulations on that. I mean, I realize that those are pretty simple commands, right? But you have now just spun up a fully realized Cassandra database in a couple minutes. You're creating a table, you're ready to go. Now, 2 minutes before I pass it over to Patrick to get more into some of the data modeling stuff, just because I want to point this out for you developers out there. Right now, we're just working with SQL SH console, right? Even though we're not doing application dev today, when you want to work with your Cassandra database with your application, notice this connect button up here. So there's a REST API, GraphQL, for those of you who are doing that, which is seriously cool in a lot of ways we're not going to get into today. These endpoints are generated for you automatically. The driver is that one I was talking about, that secure bundle. So again, this is the point where if you use the latest drivers, could be Java, Node, C#, C++, C, Python, all the main languages are there. You can download the Secure Connect bundle. This will give you like a Fort Knox level secure connection to your Astra database, right? With that one thing. So anyway, I just wanted to point that out before we move on. All righty. Wonderful. Okay, great. And I do see a question from Hamida. Is users by city a partition or a read? So users by city is the table itself. City is the partition, what we're partitioning by, right? That's going to be our partition key. So if you remember the example from before, we had Phoenix and Seattle. So I've got a table that's got, in that case, 2 partitions, right? And those will be stored in physically separate partitions in my database. So then later on, and let me know if I'm not getting your question right, by the way, Hamida, but later on when you go to read from it, then when I perform my select statement, I'm going to say select star from users by city, where city equals Phoenix or city equals Seattle or something like that. And in that particular case, it will literally go and read. It'll grab that one partition and it'll go read that partition out. It's not unless I did like a select star with no partition key that it would actually pull them all. So let me know if I'm getting the question, getting you the answer that you are looking for. Okay, with that, let's go ahead and continue on. I will give it to Patrick to get. You came in right at the right time, by the way. That's wonderful.
I like to plan things, but better.
Yeah.
I mean, planning is great when you do it good.
Yeah, so Patrick is now going to go through the art of data modeling. This is honestly like one of my favorite sections because, again, for those of you coming from a relational. Oh, and Patrick, I should tell you, when I asked the survey question in the beginning about how many had experience with Cassandra, everybody was brand new to Cassandra. Everybody.
Wow, that's awesome though.
That is awesome.
Cool. Welcome to the family.
Yeah, totally. So this is like a cool section because it's really you understand some of the things I've been talking about and why we're doing them that way. So with that, Patrick, go.
Well, and actually, I'm really happy to hear that because I know that the MLH community is a lot of newcomers to this global community of developers and people who are out there building cool things, and I think this is a great opportunity for you to see like where things are heading in our industry. Like I mentioned, like Apple. I work with Apple every day. because that's, if you want a job building things that are really cool, you have to think about a different scale. And this is an opportunity for you to see that. Relational databases have ruled the database world for a long time. Probably longer than I've been in this business, that's for sure. But they have a purpose. But when we do relational database modeling, it's really based on this whole thing around tables. And the concept of a database table was really old, but that's what started this whole idea of relational databases, is tables of data that needed to be joined together. They have a relationship between them. So when we build relational data models, we think of this domain of our data, like how big is our domain? And so we do our tables designs, and we use this thing called normalized forms. If you've ever taken like a more formal course in relational databases, you learn about this third normal form, second normal form. Really, it's just how broken apart your data is, and then when you do the query, you use a join. So you'll join this table based on this ID to this ID. So like when you see like this, I think we hit the next button. I think there's a bigger explanation there. Okay, that's fine.
You want this one?
Yes, I want that one.
You want that one?
And then you're gonna go back.
Yeah,
so
yeah.
Here, let me wreck your flow. Okay. So like normalization is what we expect in a relational database. This is probably when you first ever started using a database. You're told, create an employee table and a department table, and then you have a user ID and a department ID. And if you want to find out what person is in what department, you do a join, and that's totally cool. The thing about normalization is it was really built around saving disk space. And I don't know if you've been on Newegg lately, but buying disks is cheap. That's not the problem anymore. The problem is that we have like a bazillion users on our sites. And, so when you look at a website like Netflix has like 20% of the internet traffic on a Friday night. That's a different problem. Do you think Netflix is sitting there worried about disk space? Not really. That's not their problem. Their problem is making sure that when you hit play, that you get it, right? That's what you want. And doing a join gets in the way of that. And that's because it creates more complexity. And that the reading of that data takes a lot of work from the database standpoint. So go back one. I'm going to let me reorder your deck. Thanks.
No worries. No worries. I'm flexible.
Yeah, NoSQL, and the word NoSQL, all right, it's an industry term. We talk about it. NoSQL, it's not SQL, but it's more in terms of how the data models are different. In this case, what we're doing is we're basing all of our data modeling on the application. So instead of starting with the database and then building an application around it, this is like you're starting with the thing that you're trying to build. And hey, I want to make some money writing an application, not creating a database, right? That's where you make the money, is in the application. So start there. And when you build your application, you're looking at like all the things that need to support it. If I have users that log in, I need to have a login table. If I have profiles, I need to have profiles. If I have comments, I need to have a comment table. So eventually, as you're building your application, you start building out. This is what we call a workflow. So we identify our workflows. We define those queries that fit into those workflows. Like people click on the next thing, the next thing, the next thing, and each one of those clicks is probably going to generate a database call. And this is just how we build applications now, 2020. not pandemic applications, but in modern applications, every application has a little bit of data in it, and that's just the way we do things. Mobile applications especially. So when we know our queries ahead of time, and this is the art part of it, is making sure we get a good, clear understanding of what our application is requiring. So you can hit next. There you go. Denormalization. So how we go from a relational data model to a NoSQL data model and actually denormalization isn't just left to that, but denormalization is a technique that you can also use in relational databases. What that means is that you are taking your data and combining it. into a single table. So instead of having a table for employees and a tables for departments, now I'm just going to put a field called department in my employee table. And that seems really like duh. But yeah, that's what that is. But what you're doing, sure, potentially you could have, now you have a duplicate of data. You have a department table that has just a list of all the departments, and then the name of each department is in every employee record. Okay, well, wow, we just started using more disk space. Who cares? Now I can find out which person is in what department in one query. I could just say, hey, give me this employee with this user ID and give me all their information. This is the key for speed. When I ran, for years, I ran large-scale applications. Both David and I did, we used to work together in our past life. And what we did was we ran databases and applications to scale at crazy levels. And this was a trick that we did in relational databases, is denormalize your data, minimize the complexity of the query. That's what we're doing. So this is some real world stuff. Even if you stick with a relational database, do this. Denormalization is a key for speed. You get that quick read. The downside is that it adds a little more complexity to how you think about your data. Mm-hmm. You're not just inserting your data in one place. You may have to insert it in more than one place. But the payoff is application speed. Next.
And Patrick, just so you know, we've got about 20 minutes.
2-0. Awesome. Oh, let me slow down. Kidding. How's the speed, by the way? I can't see the chat because I'm not in the Zoom.
Nobody has complained that you're talking too fast just yet. I think though, folks may understand that we're going a little faster. Perfect, really, great. Okay, there you go.
We're always worried about that.
Speed's good. Speed's good. They're right with us.
I don't want to be like the Disney jungle ride guy.
Yeah, right.
where then like I'm talking, all of a sudden I shoot a hippo. Hey! All right, so not that. So how do we design? What's the design step process? And this is actually a tattoo that I have somewhere on my body, and I won't disclose where, but it is a tattoo that I have. This diagram right here, because I don't want to forget it. And what you're starting always with every single database is these entities, and then you build the relationships. And entities are just a concept in every database. And what is an entity? Let's just quickly touch on that. That's a thing, right? So like a user is an entity. A video is an entity. And just think of it, it's like that's your noun. This is starting to sound like we're breaking down sentence structure. Mm-hmm. Sixth grade English.
Kind of does feel like it sometimes.
It does. Yeah. Like, I feel like I'm in grade school. But you have entities when you're building an application. You're going to have things that have properties, like a user has an email, that sort of thing. But they always have relationships with something else. Very rarely do you build a database with an island of an entity. Like I'm just storing one entity and that's it. I say that because I say rarely, because sometimes you do, but most times you do have relationships. Now you either express those with a relational database where you do joins, or we build it into our data model. Go back one slide. Yes. So when we're going from left to right, I'm going to walk you through all of those steps, and we'll see how that goes. So next. So we're starting with those this conceptual model, like, okay, I'm building a really cool video sharing app. I'm going to call it TalkTick, and so I hear it's going to be huge. By the way, TikTok, huge Cassandra user.
Yeah, there you go, actually.
Yeah, they actually had a really cool article about how they didn't realize they were going to have so much success, and thank God they used Cassandra.
I didn't really point out a lot of the Cassandra users out there. Netflix, TikTok, Apple, Sony, if you're doing stuff on the PlayStation, that's totally happening. A bunch of banks, credit cards,
Walmart,
FedEx, Home Depot. Yeah, I mean, there's so many big players that use Cassandra as their back end, and that says a lot, right? So I just want to point that out, actually.
And I've taught them all how to do this, and you can too. Yeah. Yeah, so the rule of thumb with Cassandra is if you see somebody doing something at scale, they're probably using Cassandra.
Yeah.
Like TikTok, Instagram's another big
one.
user.
Yep. Spotify.
Spotify, another big user. Yep. Spent a lot of time in Sweden. Okay, next. So whenever when I take that design process, I'm taking it. Really, what I'm doing is I'm thinking about my application. So if I'm building that video sharing application, I hope that you know what you're doing, but you're looking at your application. You're not just being really general about creating databases. You're thinking about how my application works. That's what we call an application workflow. If you were sitting there with a notebook, you could scratch this out real quick. Like, here's how I want people to interact with my application. It will tell you a lot of things about how the data should go when you do that. Hit the next button, please.
I'm responding to something. There you go.
Yeah, you're doing a great job of multitasking. Mm-hmm. So when we're sketching out our map of our application and we're seeing how it works, what we then find is you'll find the queries that need to come out. So, for instance, if I have a video that people can comment on, so I have people, video, and peoples and videos, and so a person can comment on a video, and a video can have comments. So there's this kind of there's many-to-many relationship. Well, that's two particular queries that I need. So if I was to display a video with all the comments underneath it, then I would take it from the point of view of the video. If I was to look at my user profile and say, how many videos have I commented on? I would take it from the point of view of the user. So, okay, I got a couple of queries that I need to be able to support. They're similar, but they're different, very different. And so we just found two. That's awesome. Okay, next. So now what I'm going to do is I'm going to think about, like, what does that mean? Well, I'm going to select from this table called comments by user where the person has an ID. And I'll have that ID because they've logged into the application. Same with the video. If I click on a video, it's going to have an ID. I mean, I don't care what you're using, React or using Angular or whatever, you're going to identify everything with an ID. And that video ID I'm going to use to query the database and say, give me all the comments for this video. So now I have this, like, I'm starting to glue together my application with what the database can do for me. Next, please. And at this point, I'm going to start designing out my database. And I'm thinking about, in this case, this logical data model. Logical means it's just, okay, here's all the fields that I need. Here's how I need them to behave. So my primary key, the big K, is going to be the user ID for comments by user. My primary key or partition key is going to be a video ID for comments by video. But I'm going to have clustering columns as well because I want to put some ordering against it. So the creation date, I'm going to make that a descending order so that it's in date order on both of those. So now it's naturally sorted in the database for me. Awesome. I don't have to do that work in my app because sorting algorithms, there's so many to pick from, right? And it's not a cheap operation. No. Just let the database. Mm-hmm. And so now, and I have my other fields in here, the actual, like, the person, and then, like, the video ID, like what video they were commenting on, and then the actual comment that they said. Now you'll notice that there's a whole lot of duplicates here.
Yep.
Totally.
Yeah, matter of fact, I don't know, Patrick, if you saw the question from Suhani was asking, wouldn't this lead to a lot of redundancy? Yes, but I think, yeah, that's where Patrick's going right now. Yeah.
Yeah. Great question. And yes, it does lead to data redundancy, which is something that this is something we've been kind of against when disk space was when it was super expensive.
Right.
Or it doesn't seem efficient. It is efficient though. Let me tell you, if you're logged into a large website, your data is duplicated in all kinds of layers, from caching layers to database layers to application layers. This is how you get to scale and speed, is by creatively and effectively creating the data where you need it, when you and how you need it. Sometimes it's duplicate. There's ways that we have to deal with that, though, and we'll get to that in a minute. But yes, you look at this. If I said, yay, I love that video, now that has to go in 2 places, and that's it. But for good reasons, because whenever I want to get that comment from as a user standpoint or from a video standpoint, it's a millisecond query.
Yeah, and that's the key thing. So going back to something that we were talking about earlier, to the question, right? Yes, I'm going to have some redundancy between these 2 tables, but writes in Cassandra are extremely fast, right? So yeah, I'm going to write to both these tables, but we want to optimize. Writes are so fast, generally compared to reads, that I want to optimize. I want to be able to maintain that performance at scale. So later on, if you remember what I talked about, when you want to store together what you retrieve together, that's what we're doing here. So if I want to retrieve comments by user or comments by video, then with a single read to a single partition, I can pull back all the information I need in one shot. I don't have to do a Cartesian join. I don't have to, imagine how many here, if I get thumbs up, how many here have had, SQL statements with 20 joins in them, right? I mean, I used to be an Oracle DBA at one point. That was like a badge of honor to optimize those things, but it was hard to optimize those things, right? So yes, you pay for it in the redundancy, if you will, but you're gaining on that read, and to be able to maintain millisecond performance is what it comes down to.
Yeah. All right, moving on. Next slide.
Nope. Wait. Beep. There it goes. Physical.
Physical data model. This is when we start getting into typing, and types are important, because when we throw data at the database, we want to have some assurance that when we pull it out, it's going to be what something we expected. For instance, a UUID, it looks like a UUID, and I'm going to enforce that. If I put in just the number 1, that's not a UUID. And so this is how we keep from being surprised later. This is also how we work together. Schema is how we share information with other developers in our team. And it's really important to have good, solid schema like this. So in this case, we're going to be defining in the physical data model what those are. For instance, with the time UUID, which is a special type that is like it makes a unique timestamp. Very important for that comment ID, because we want to combine the time and the ID itself. And the comment is a text field. Next. And from this, here's something I created earlier. From that data model that we're building, now we actually get to build the statements, this create table, and you see how it all comes together now. So we have our partition key, which is user ID, a clustering column, which is comment ID. Everything has a type now, and we have the clustering order by, and that keeps our order together. So now I have a descending order on that timestamp. This is pretty super cool, because now I can, whenever I insert data into it, I'm going to get it out the way I expect. My application is going to work awesome. This is the good thing. Next.
Alrighty. So with this,
I'm gonna
go ahead.
Yeah, let me wrap this up.
Yeah.
So everything you saw there, yeah, it seems kind of processy. Sometimes I just do that in my head now, because it's like this is how we do it. This is the way, right? Who's watching The Mandalorian next week?
Yeah.
Next. I know. I thought it was this weekend. And then no, it's next weekend. But it's just, if you get into the mindset of like building for my application is the most important part of this, then you'll start feeling this right away.
All right. So with that, we have 10 minutes, right? So we have 2 different directions to go, but I think I know what direction will be fun for everybody. So for one, I do have a question from Kevin. I don't want to miss it. And it's, how do you keep track of all the copies when you need to update one of them? We're going to answer that in just a minute. What I'd like to do at this moment is this. Let's go. Who wants swag, right? The swag is the fun stuff. So the repo, everything that you do, everything that we're going to continue on for the CRUD operations is here in the repo, right? So you can totally do this self-service. It doesn't actually take all that much time. What it's really going to do is it's going to go through the CRUD operations, right? And honestly, I think with 10 minutes left, we probably don't have enough time to go through all of it here. And by the way, by CRUD, I mean create, read, update, and delete. All the types of things that you need to do with any database. So it's going to step you through going through all the basic CRUD operations, right? That gives you the basic plumbing, the basic knowledge that you need to start working with the database for your applications. By the way, for those of you who are curious, we keep referencing these UUIDs, and you might be wondering, how do I get a UUID, right? I've included that in the repo, right? You'll see documentation links. We use contrived ones just because it's easier when everybody is doing this at the same time to use the same exact IDs. In the real world, in a real app, would I do it this way? No, I would actually just use the UUID method. That's here it's literally a call, right? To generate a timestamp I can use now. So I did include the documentation links and such here in the repo. With 10 minutes though, we can get over to our friend Menti. And for those of you who are with us, right, yes, I see. Yeah, she goes, I want swag. Exactly. So we've got time to do the quiz. We should do the quiz, and let's start some fun here.
And keep in touch, please. We have a great community. Getting involved in the Cassandra community is not a bad career move.
No, not at all. Not at all. All right, so hopefully you guys hear some fun little music. We've got 5 questions. So, how do you keep in touch? I'm going to give you at the end, the slides, by the way, that we were showing today are in the GitHub repo. They're at the very top in the table of contents. You'll see a slide deck link. All the slides are there. The links are embedded in there. At the end, you're going to see some resources, right? By the way, Patrick and I, we're in LinkedIn. We have the community. We have our Discord channel. All of that stuff is in those slides. So feel free to reach out. Happy to connect with any of you. And like I said, we do have a bunch of other workshops as well. All right.
Yes.
So with that, here's what you do.
Discord is fun.
With the Menti, yes, I see. Oh, great. People already have their names in. This is wonderful. That's great. They're ready to go. They're like, man, I want my swag. Stop.
A lot of purple devils. What's going on there?
It generates them. So here's what happens. When I hit enter and it starts the countdown, look at your phone. There might be in the Zoom. Look at your phone for the questions because speed will matter, right? Speed and correctness matter. And let's do this. 5 questions. You get 5 questions. First one, what is Astra?
This is kind of you threw the softballs out early.
We kind of change them up, honestly. Oh.
You throw the softballs out. Come on. But, they do get harder.
So Astra is a gateway to the stars. It's a local in-memory version of Cassandra, a development tool, or Cassandra as a service in the cloud. And correct answer is, it is Cassandra as a service in the cloud. Most of you got that right. Very good. Yes, it's not.
Gateway to the stars.
Yeah, you like that one?
There's always somebody that has to take those.
Yeah. I think that may have been me. Yeah, but yeah, it's not a local in-memory version of Cassandra. It's Cassandra as the service in the cloud. So let's see what our leaderboard looks like. Now, the first one is pretty much going to go off of that correctness and speed. Kevin was the fastest. Nice, Kevin. And Kevin, we do have your question. I'm going to get to that. And I see Harshil and Johnny in 2-3. Now, by the way, this game, it's anybody's game, always.
Oh, it changes up so fast.
Right? All right, next one.
So fast.
What type is used to store both an ID and a timestamp? Hint, Patrick just talked about it. Yeah, timestamp ID,
just said this one.
all in things one ID, time UUID, or time ID.
It's one of my favorite types.
It is a really cool type, actually. I
use it a lot. In banking, especially.
And let's see. Yes!
Yes!
You were listening! Time UUID is it, yes.
We got some people paying attention out there.
We're talking fast. They're paying attention. It's wonderful. All right, let's see what happened on our leaderboard.
Kevin, can you hang on?
Oh, that's a close. Wow, that was very close. Oh, Burker was the fastest, but it looks like Kevin is hanging on to the lead for the moment with Harshil and Burker. All right, let's see what happens next. Again, anyone's game.
Sharpen your pencil, Kevin. This is tough. That's not a big lead.
What is a primary key? Same as the partition key. Uniquely identifies a row. It's a column in the partition key. It's the main house key.
Magnowski. Who uses keys anymore? I have an electronic lock.
You're just waiting to get hacked. Just waiting to get hacked.
Yeah, it's great.
All right, let's see. It uniquely identifies a row. Wonderful. Yes. Now, for those of you who answered same as partition key, technically, you only had one column in your primary key. That would be the partition key. But its main purpose is to uniquely identify a row, right? So
it is partition key and clustering columns.
Yeah, or, right? You could have 0 more of those. All right, let's see what happens.
0 more.
Ooh, I saw some fast times.
Hanging on.
All right. Oh, Kevin's keeping the lead.
He heard me.
I see Suhani, though, kind of working up. So we have Kevin, Patricia, and Harshal, and top 3. Burker, you're right there. You're right there. It's so close.
Yeah,
this is a close game. All right, we got 2 more of these.
Kevin could stumble. Patricia could take it.
All right. What is the partition key? A designated field in your table structure to partition your data. A consecutive number applied to each new record. The key to partitioning this reality from the next. An optional table field for optional partitioning. These are kind of tricky to put next to each other. And let's see what happens. Yes! I am so impressed with this group today. You guys are rocking this. Yes, it is a designated field in your table structure.
We do a lot of these, and sometimes you wonder, is anyone listening?
We also wonder, are we like, the stuff we're talking about, are we not doing it well or whatever? This is great. You guys are really listening. You guys are on it.
Just feel good.
Yeah,
it's important.
It's wonderful. All right, let's see what happened
what's going to happen with Harshal? Oh, Patricia, what happened?
Ooh, Suhani jumped up with the fastest score to 3rd place with Kevin, Harshal, and Suhani. 1 more left.
It's pretty much between Harshal and Kevin at this point.
I don't know. I've seen it switch. In the data modeling framework, we start modeling with the physical data model, with the logical data model, with the conceptual data model and application workflow, with copy paste from Stack Overflow. We know the right answer for that.
Focus. Oh, this is so hard. I'm losing it. I can't watch this. All right, well.
Boom! With the conceptual data model and application workflow. Perfect. Yes. When data modeling in Cassandra, you start with those application workflows. And I guarantee you could literally start writing out a UI on a napkin, and that is enough to start generating the queries that will generate your tables. Right there. Awesome. Everyone did such a good job. All right, let's see what happened.
I'm really impressed.
This is the one. This is the one right here.
Oh.
Oh, Kevin kept the lead. All right. And Suhani got up there. So Kevin, Suhani, and Harshal, go ahead and reach out to me. I'm putting it in here.
Oh, man. When I saw reordering, I thought Kevin was going to get reordered out. And I'm like, oh, no.
Yeah, so good job. Our top three, Kevin, Suhani, and Harshal. Reach out to me at david.gilardi@datastax.com. Let me know, that you're one of the swag winners. And then we'll get you set up, right? We'll send you some follow-up and get you some swag. And excellent. And
I like this is set up November 3rd, man. I'm having a heart palpitation watching the leaderboard.
Woohoo! Yeah, I see Suhani and Kevin. Yeah, great. I'm glad you all like that. By the way, Kevin did have a question. Let me answer it real fast because I promised him I would. How do you keep track of all the
winner? You get to ask your question.
Yeah, how do you keep track of all the copies when you need to update one of them? This is something I love about Cassandra, right? So when you are storing data in Cassandra, you actually store by something called the replication factor. That default, by the way, is 3. So I'm going to store 3 copies of the data somewhere in my cluster, right? So what happens is when I need to update some data, I'm actually going to asynchronously update all of them, all 3 of them, right? That's going to happen automatically by Cassandra. Now, for some reason, let's say a node was down, or for some reason one is slightly behind or something like that. Cassandra has been built from the ground up with all sorts of resiliency mechanisms in there to ensure that if you use, it's called consistency level. In particular, I'm just going to tell you, use local quorum. Just start there. Local quorum is going to ensure when you do that in your reads and writes that you have what we call immediate consistency, meaning when I write data, that if I read it right away, that I'm guaranteed to get the data that I just wrote, right? So even if a node was down or for some reason one didn't update, there are mechanisms in place that will check for that consistency when you perform that read, will return you back the most recent result, and if needed, will automatically repair any data under the hood. We can't get into a lot of detail about that right now. I would geek out about it for like 10 minutes. But yeah, so that's being handled for you. That replication is also being handled for you. So when you write data, that's automatically happening. So hopefully they answered what you were looking for, Kevin. Oh, and Naman says something for the 21st person. you know.
Yes, you get a database.
Yeah, there you
Free
go.
one.
You get a free database. There you go. Right?
Free database.
All right.
All the rest of your life.
All right. So to wrap up, and again, all of these slides, they're in the GitHub repo. The links are there, but I do want to point them out. That developer site, you see that datastax.com/dev. That is actually a really cool resource. We use Katacoda, which is from O'Reilly. Again, this is all free, where you can go into a ton of training. Cassandra, data models and stuff, all embedded right there in the site. So if you have a particular path, whether it's admin or developer or something, go to /dev and check it out. Also, you can see the Katacoda scenarios. We link to you directly. There's a sign up for it, but again, that's free. And there's DataStax Academy. I mentioned that in the beginning. Again, all of that's free. There's a ton more information that we can provide and that you can get at. And then lastly here, don't forget our community, community.data.com. We're all over the place. Feel free to reach out. And the best place is probably the Discord chat, honestly. That link is in the slides. If you go to the Discord, you're going to become part of that group and all those folks in the chat, but then you can reach out to us. And again,
and we don't have secret names, by the way. It's not like you're going to find like starry-eyed 123 is like David. No, David Gilardi, Patrick McFadden. We have plain names.
Yeah. And one other thing I want to point out here: if you go to the parent project there, you will see a whole set of other workshops and stuff that are in here that are designed similar to this, that are self-service, that you can get into and check out some other learnings. So.
Yeah, there's stuff in there for Node, for Java Spring, if you want to try that. Python. There's some front end stuff that's happening soon. We're going to be doing some work with React, and go a direction you want to go, and then ask questions. When I say stay in touch, that's what we want. Feedback is important, and if you want, at some point, you want to come talk about what you've learned. We have some great community resources for if you want to do a meetup.
Yes.
I would be happy to interview you. I do these Zoom interviews, which are fun. They're like a little 5-minute interview, but it's just a good way to get out there and talk about your experience. It helps other people in our community.
Exactly. And with that, thank you, everybody. I'm going to leave you some cool tunes. I really appreciate all of the interaction, the questions. They were wonderful. You all did wonderful in the quiz. And have a good rest of your. With that, see you later.